Okay, so what we're going to do in this lesson, look, I didn't start with alrighty. Okay, I'm really proud of myself. I don't know if I can handle it. Like and subscribe if you like it. I'm just kidding. I don't care. So what we're doing in this lesson is that we are adding and subtracting and multiplying and dividing with radicals. Okay, so what we call that is performing operations, add, subtract, multiply, divide. We're going to start with adding and subtracting. I think you're going to find this fairly reasonable and very, very similar to if you think about when you started algebra, the phrase combine like terms. Okay, so that's what I want you to kind of think about in the back of your brain as we do an example. So really what we have is if you have something that has the same radicand, you can add them together. So for example, 2 times the square root of 11 plus 3 times the square root of 11. You're going to consider this kind of like an X when you did combining like terms back in the day. You're going to do 2 plus 3, which is 5, square root 11. Done. Don't do anything else. Just stop. Okay? Same thing if you're subtracting. So let's say I have 8 times the square root of 17 minus 4 times the square root of 17. 8 minus 4 is 4. And we keep that square root of 17 right here. That's all we're doing here. However, the tricky part comes when we don't have square root radicands that match. And so sometimes you're going to have to simplify these so that they match. So let me give you an example of what I'm talking about here. What if you had, let's see, I'm going to back up just a little bit. Find a good example. Yeah, I like this. This one's a more complicated example than what you'll generally see, but I like to do that in the video so that you'll see what I mean. So here we go. 3 times square root of 75, okay, minus 6 times the square root of 48, minus the square root of 27. Gross. We can't do anything with this. However, we do know that all 3 of these numbers can be simplified. It's just going to take time to do it. So let's start with that 75. Okay. So the easiest one that I think of when I think of 75 is 3 times 25. And 25 is a perfect square. So that means that I can write that as 5 times the square root of 3. Okay. But look, I've already got this 3 out here. Okay. So really this becomes 3 times 5 times the square root of 3. Okay. Because that square root of 75 is 5 times square root of 3. Still got that 3. So I'm going to change this to 15 square root of 3. Okay. Let's do this next one. Square root of 48. Square root of 48, 48 is 6 times 8. 6 is 2 times 3. And 8 is 2 times 4. 4 is a perfect square, and I've got these little 2's. So let's think about that for a minute. So we've got definitely the square root of 3 underneath. We're going to pull this square root of 4 out to be a 2. And we're going to pull these 2 2's to be 1 2. Okay, so this 2 times 2 is really 4. So I'm going to do minus 6 times my 4 square root of 3. Okay, negative 6 times 4 is negative 24 square root of 3. Now I need to deal with the 27. Okay, so square root of 27. Are we having fun yet? Yes, we are. Okay, square root of 27. 27 is 3 times 9. And 9 is a perfect square. So that's truly 3 from this 9 times the square root of 3, which is this leftover 3. Okay, so we're going to do minus because that's a minus sign. And it doesn't have anything else, so I can actually pop it down onto this line right here with my others. Okay, so now I have 15 minus 24 minus 3 is negative 12 times the square root of 3. So it does take some work, but you're going to get a lot of really good practice simplifying radicals. And honestly, guys, we're going to come back to this year. No, not year, the whole year, month after month, week after week. You're going to see this so much. You're going to get tired of it. I don't care. You need practice on this. So simplify these radicals and find, if you can, the same radicand. And then just add those front numbers or subtract those front numbers together. So one thing, though, to know is if I had something like, okay, 15 times the square root of 3 plus 7 square root of 5 minus 3 square root of 3. So like, what if this was something entirely different? This is not a like term. Okay, so we would do the 15 square root of 3 minus 3 square root of 3. That's 12 square root of 3. And then we would just leave that 7 square root of 5 out here by itself. Okay, those are not like terms. Just like if you had something like 3x squared plus 2x plus 2. These aren't like terms, and we just write a string of numbers like that. It's okay. All right, good luck. I think I'm going to put the next video or the next topic on a separate video just to make sure this one isn't too long. So stay tuned.